Hello everybody, my name is Natalia and today I'm going to be talking about condensation polymerization. There are so many polymers within our society that we depend on, such as bakelite, polyvinyl chloride, polystyrene, polyamides, polyester, and natural polymers. But in today's lesson, we're going to be focusing on polyamides and polyesters. So polyamides are used within the manufacturing of clothing and carpet due to having high strength, abrasion resistance, and other useful properties. Polyamides have other uses within our society such as airbags and more. Polyesters are well known within the clothing industry, but they're also used to make plastics. In fact, polyester is a common plastic within our society. All in all, there are so many different types of polymers within our society that play a huge role in our lives, and we highly depend on them. So here are the learning goals throughout this lesson. You will be able to explain how polymers are used in day-to-day life, react a dicarboxylic acid and a diol to create a polyester, react a dicarboxylic acid and a diamine to create a polyamide, identify polyesters and polyamides, differentiate between polyesters and polyamides, and lastly, do complete structures and line structures of polyesters and polyamides. So throughout the video, you can follow along through this worksheet to have a better understanding. So today, I'm going to be introducing you to amide and ester linkages. I'm going to walk you through each step of the reaction and show the new products produced. Condensation polymerization is a reaction between two monomers that will produce a large polymer with the loss of a smaller molecule. In my cases, that will be water. So we're going to start off with me showing you how to create a polyamide. And before we start, I just want to mention that the boxes in between the two molecules I just showed just represents a chain of carbons. So this H on the amide is going to bond with this OH. You're going to have your C double bonded O. So this one is, so these two are going to create, these three are going to create H2O. So your N is going to bond with the C. Then you're going to have your C, the continuation of the diamine. So right here is our amide linkage, is that this is a polymer. So there's going to be thousands of bonds. And for that to happen, you need to have a carboxylic at the end and an amine at the end of the chain. With our diamine here, if I bring another dicarboxylic acid, it's going to react like what happened here. The OH is going to bond with the H here, creating water, separating. And then the N is going to connect with the C. And here you have another amide linkage. So the same thing's going to happen on this end. We have a carboxylic acid and it's going to react again with a diamine. So now we're going to be focusing on polyesters. So polyesters, the same as polyamides, the only difference is that it's ester linkages. So we're using dicarboxylic acid and diol. So what's going to happen? The H at the OH is going to bond with the OH over here on the carboxylic acid, and it's going to create H2O. And then once that H2O is created, what's going to happen is this O is going to bond with the carbon now. Here, because this left, the carbon has nothing now, it's going to bond with the O on the diol. So it becomes O, and then we continue the chain from the molecule on the diol. So what happened here is that we got an ester linkage. At the end of this chain, I have a carboxylic acid, and at the end of this chain, I have an OH, which over here, with my carboxylic acid, it will react with another diol. And then what happens is the H and the OH come together, creating water. The O will bond with the carbon, creating another ester linkage. Please ignore the H. Creating another ester linkage and having an OH, carboxylic acid again at the ending of my chain. It will just keep reacting. The carboxylic acid with another diol and the OH with another dicarboxylic acid. Okay, so now I'm going to be demonstrating two examples, one of a polyester and one of a polyamide. So the polyester we're going to be solving is Dacron. Dacron is full of ester linkages due to being a polyester. So we have a 1,4-benzene dicarboxylic acid, also known as terephthalic acid, with the chemical formula of C8H6O4. And that will be reacting with ethane 1,2-diol, also known as ethylene glycol, with a chemical formula of C2H6O2. You could pause the video if you want to solve this and then check later on. The H on the ethylene glycol is going to bond with the OH on the terephthalic acid, creating H2O, which will cause the O, the oxygen, to bond with the carbon. Then we have the carbon double bond O, and now we have the carbon bonded with the oxygen from the ethylene glycol, and then we shall continue the chain from here. So here we have just a part of Dacron, because Dacron is a polymer, and we know that polymers have thousands of bonds. So this is just a part of Dacron. We could get this carboxylic acid at the end and react it with the OH on a unit of Dacron. So here we know that the OH and the H are going to create H2O, and then the oxygen is going to bond with the C, with the carbon. So we have C, double bonded O, and then we just continue the whole chain, and then our OH. So as you can see here, we have an ester linkage here, an ester linkage here, and another ester linkage here. And this is how the line structure would look like. So for example 2, we're going to do nylon 66, which is a polyamide. Nylon 66 is made of 1,6-hexane dioic acid, also known as adipic acid, and the chemical formula is C6H10O4, and it's going to react with 1,6-hexane diamine, also known as hexamethylene diamine, and the chemical formula is H2N bracket CH2 bracket 6NH2. You could pause the video now and solve it yourself and later on see if you did it right or wrong. So what's going to happen is that the H on the NH2 is going to be attracted and bond with the OH, creating H2O. And then what's going to be left is an N and an H, and that NH, mainly the N, is going to bond with the carbon on the adipic acid. And so the N is going to bond with the carbon, and then we're going to continue the rest of the chain. And right here, also, since nylon 66 is a polymer, this is just a part of nylon 66. So like the Dacron that we did, we could just call this a unit of nylon 66. And here you could see is our amide linkage. So here with our H2N, I'm going to take this unit of nylon 66 and I'm going to react the carboxylic acid at the end of this unit with the H2N here. So we know that the OH and one of the H's become water, H2O, and so what we have left is our nitrogen, and our nitrogen is going to bond with the carbon, so it'll be carbon, and then we're going to continue writing the rest of the chain. So what we have here is that we have an amide linkage here, an amide linkage here, and also an amide linkage here. Nylon 66 is a polyamide, and being able to have the carboxylic acid at one end and the amine at the other allows for more reactions to occur. And so here is our line structure of nylon 60, just a part of nylon 66, the polyamide. So that's the end of my condensation polymerization lesson video. I really hope you understood. Thank you so much for listening. I really hope you enjoyed it.